All right, so today we are talking about dividing a binomial into a polynomial. So we've already done monomials but now I have a binomial here and I want to divide it into this polynomial. So one thing we can do is long division. Before we start talking long division though, let's see if we remember how to do long division with something like, oh, I don't know. How about we want to divide, I don't know, 270, and I want to divide it by 24, something like that. Do you remember how to do that with long division? First of all, long division, remember had this thingy? Who goes over here if I'm doing this? 24. And then 270 goes in here, right? Go ahead and do the long division out. See if you remember the steps. Fraction. Did you remember the steps? So let me walk you through if you've forgotten, because it's probably been a long time since you've done long division. You take your number out here, 24. 24 can't go into 2, so then I look at put two digits together, 27. How many whole times can 24 go into 27? One whole time, right? So you put a 1 at the top, and then what do you do with that 1? You multiply by what's out in front, right? So 1 times 24 is 24, and then what do I do with these? You subtract them. 27 minus 24 is 3, and then what do? You bring down the 0. And then I kind of repeat the process. I ask myself, how many times can 24 go into 30? What'd you say? One whole time, right? One whole time, so I put another 1 up top. Then I do 1 times 24, I get 24. I minus, I get a 6. There's nothing left for me to bring down, so you used to have 2 options. Well, you might have had 3 options. You might have gone into decimal land, put a decimal, and then start adding zeros and keep going. We're not going to do that. Do you remember writing like R6 for remainder of 6? Okay. So basically, that's what's going on. 24 will go into 270, 11 whole times, and then I have 6 24ths left over. So we are going to have ours in fractions. So it goes in 11 whole times and 6 24ths. Now I know 6 24ths can be reduced to be 1/4, right? So my real answer could just be 11 and 1/4. Since these are numbers, I know it's just the mixed number 11 and 1/4, but ours won't combine quite so nicely. But you remember the steps? So, believe it or not, the steps are very similar when you're doing this. So I'm going to start by putting, do you remember the names of the things? Like what is, this thing had a name. It starts with a D. I. See, I think that's that one. Even I'm messed up. I think that's the divisor, that's the dividend, and then the answer is the quotient. I'm pretty sure. I might have it backwards though too. So anyway, I'm going to put the n minus 10 out in front. Oh, before you do this though, you want to make sure that everybody's in standard form. The other thing you want to make sure is that every degree is represented. So what I mean by that, see how the highest one here is to the 4th? I want to make sure I have a term for every degree working my way down. So I have a n to the 3rd, n to the 2nd, n to the 1st, and then no one at all. If I was missing any of them, yeah, you'd have to plug in 0 as a placeholder. Otherwise, everything's going to get all messed up. So we'll do some examples where we need them. But in this case, I check everything's there. I don't need any placeholders in this one. So I'm just going to copy that in, make sure I don't mess up. Alright, so there's my math. Okay. One thing you want to keep in mind while you're doing this is you want to keep the same exponents in each column. So if I ever have to write in n squared, for example, it's going to be in this column. If I have to write n to the third, it's going to be in this column. If I write n to the fourth, it's going to be in this column. I want to keep all my columns the same degree, okay? So this part's a little bit different. Here we ask ourselves, okay, how many times could 24 go into 27? The question that you're going to ask yourself, you don't worry about the 10 at all. You really just look at the first term, n. I ask myself, what do I need to multiply n by to get n to the fourth? N to the third. So that goes up top in the n to the third column. And now it's kind of the same procedure. I'm going to take the number on top and multiply it by what's out in front and put the answer underneath.
So what happens to the... Never mind.
Okay, so it's always just the first term. What do I multiply that first term by to get to this first term? So n times n to the third will get me n to the fourth. Okay, so I have a number up top. I'm going to multiply it by what's out in front. So n to the third times n is n to the fourth, so I write it in the n to the fourth column. N to the third times negative 10 n to the third. Once you multiply the number on top times what's out in front, what did you do?
Subtract.
Now you subtract. Here, watch though, because I don't want you to make this mistake. You have to subtract this whole line, which means you're subtracting both of these numbers. So, yes, now you are going to turn into a negative n to the fourth, but what happens with this? That turns into a positive, because I'm subtracting the whole line, right? So now, watch what happens. N to the fourth minus n to the fourth cancels out. Every single time, that should cancel out. If it doesn't cancel out, something's wrong. You've already messed up. Negative 18 plus 10 is a negative 8 n to the third. So once you subtract and you get your answer, then what did we do?
Bring everything down.
I bring down the next number. So I bring down plus 74n squared. And then I basically repeat the process until there's nothing left for me to bring down. So I'm going to ask myself, what do I multiply n by, the first term here, to get the first term here? What do you multiply n by to get negative 8n to the third? Negative 8n squared, right? So that's what goes up at the top in the n squared column, negative 8n squared. And once I have a number at the top, I'm going to multiply by whatever's out in front. So that'll get me negative 8n cubed plus 80n squared. But then what do? I subtract. So now you turn into a plus, don't you? Right? That one's now plus, and now this one, I scribble it out and I write the minus. Don't do this, right? I see kids do this all the time. They have a plus sign and they want it to be a negative, so they do this. Now you don't know what the heck it is. Is it a plus or a minus? I don't know. Cross it out. Be clear, right? It's easy to change a minus into a plus, but to go the other way, you can't. So now I've changed both signs. Oh, lo and behold, those first ones cancel out. How nice. That's a nice little self-check every time. That first term should always cancel out. If it doesn't, something's amiss. Don't go any further until you figure it out. These two, what am I going to get? Negative 6n squared. And then we just repeat the process. So I'm going to bring down the next term. See if you can figure out the next number that goes at the top without me saying anything. Just get that number in your head. What's the next number that goes up top? Do you have it? Yes, negative 6n is correct. Hopefully everybody got that. So up top, I have negative 6n. I'm going to take that, I'm going to multiply by what's out in front. Once I multiply, now I subtract, so I have to change both signs. So you're now a plus, and you've become a minus. First term cancels just like it's supposed to. Add those, I get a negative 3n. I'm almost done. I'm bringing down my last number. What number goes at the top? Just a negative 3, right? So now I do negative 3 times all that. But then you must subtract. So I'm really going to add both, add that, and now minus that. 3 n's cancel. I'm left with a 1. What do I do with that 1? You're just going to write it as a fraction. Since it's positive, I just write plus 1 over whatever you were dividing by. I was dividing by n minus 10. That's it. That's my final answer up at the top there. This whole thing. So if there was an answer line, that's what I would put on it. That whole crazy thing. Is everybody okay how I got the remainder, how I wrote it like that? It'll just take whatever your remainder is and divide it by your divisor. And that's my answer. What does it mean if you end up with a remainder of 0? It goes in evenly, right? Oh boy. Like if you do 5 divided into 80, doesn't it go in evenly? So you would have a remainder of 0. Cool! Isn't it kind of fun? Once you try a couple, maybe. I don't know. Should we try another one? Well, we're gonna... I don't know. Thought I'd be nice. I thought you would all respond with a resounding, yes, please, another one. Haven, can you read for me the second one?
Number 6, yeah. B to the third plus...
What is it, b?
Yeah, B.
B to the third.
Plus 18B squared. Plus 72B. Minus 73. Divided by B plus 9.
B plus 9. Do you want to try it by yourself?
Yes.
All right, let me give you a minute.
Is this on the paper?
Yes. Yep.
When you like multiply the binomial, like if it's plus 9, would it stay like plus, or would it just always be subtraction? Like I brought
So,
the v squared up top,
yeah.
and I multiplied the binomial by v squared, so I have v cubed plus. Okay, and then would I add them?
No, because now you have to subtract them both. So whatever signs they are currently, you change them both. So now this becomes a minus, and so does this. And now I guess you could think of it as adding. So those are going to cancel, and then negative 18 minus 9 is going to leave you with a positive 9v squared. Does everybody have the same first step as I do?
Yes.
Okay, so then if I continue with the next step, I bring down the next term. What would I multiply v by to get 9v squared? Someone said something. A positive what? 9v. Notice I'm also including the sign, right? Positive or negative. So positive. Now I do positive 9v times everything out in front. 9v squared plus 81v. But now I need to subtract them both. So you're a minus, you're gone, and that's 9v. Bring down my last number. What do you multiply this by to get this?
Wouldn't it be a negative 9?
It would be, thank you. What do you multiply that to get by to get that?
You just change the stop as well. No.
Negative 9. So I put a negative 9 there, and now do negative 9 times all that. Negative 9v minus 81. However, now you come in and you need to subtract both of these. So you become a plus, and so do you. That cancels, and that leaves me with a remainder of 8. And how do I know to stop? Because there's nothing left for me to bring down, right? We're not going to go, I don't even know how you would go decimals. You can't. You're done. There's no more numbers for me to bring down. That's my remainder. So I just put positive 8 over v plus 9. And there's my final answer. These are a bit difficult to check. So just look for your self-checks along the way that these are always canceling out. If they're not, something's wrong. You can check it. You would multiply v plus 9 times this. And you should get what's in here. It should work out nicely, even with, right? Because if I do v plus 9 times this, they're going to cancel and I just get 8. So it's not that bad to multiply this into that. It just would take a while, right? Because I'd have to do v times all that and then 9. Yeah, 9 times all that. You can do it. It's just annoying. Okay, so I said we would do, we don't have much time. Is there a number on there that skips over one of the degrees? No? I'll have to make one up. So, let's make one up. Say I had... Say I had that, and I wanted to divide it by, I don't know, x plus 4. I have no idea how these numbers are going to come out. But before I do anything, here's what I have to do. X plus 4 can go out in front, but see how I'm missing an x to the third term? It goes x to the fourth and then x squared. I have to have every single degree represented. So I'm going to write x to the fourth, and then I'm going to write plus 0x to the third. So it's not really there, right? Because 0 times anything is just 0. It's gone, but I need a placeholder. I need somewhere to put all my x to the thirds. So if I don't have it, I'm going to get all messed up. So plus 2x squared plus 4x plus 8. Now everybody else is there. 4, 3, 2, 1, none. So you always want to check before you start going. So, I don't know. I'm just going to see how these numbers come out. I have no idea.
Wait, how did you get the negative nine? Or the positive nine?
By messing up, I guess. Yeah, it should have been an 18, huh?
Yeah.
Crap. Dang it. Is it a minus 68 at the end?
Yeah.
280? Is that a remainder?
Yeah.
All right. See you after lunch.